Okay, so this video we're going to do the back page of that modeling activity. The golf ball is hit, so its height is h feet after t seconds, and you probably realize that, oh, that's a bad axis. But if I hit a golf ball, of course, it's going to go up some point, it's going to come down. How high it goes depends on how well I hit it, and it also depends on the club. Alright, so let's figure out the initial height of the ball. Alright, so the axes here is, even though this says x and this says y, my function is h of t. So that means t is my independent variable. So we're going to let this be t. H of t is my dependent, so this is going to be h of t. So t is time, and that's in seconds. H of t is height, and that's in feet. So it kind of makes sense to you. It's intuitive that as time goes on after you hit the ball, the golf ball gets to a certain height in feet and then comes back down. So question number 1 says, what is the initial height of the ball? So the initial height of the ball, well, that's before I hit the ball. And when I hit the ball is when I start the timer. So at t equals 0, that's the initial height of the ball because I have not hit that yet. So keep that in mind. We're going to do this with our calculator. So let's pull up the calculator. And we want to graph that function. And I kind of left this up here from before, and I want to show you that your stat plot is still on. If your stat plot is still on, it's going to goof you up when you go to graph regular. So go turn your stat plot off. Go to off. Hit enter. And now I've turned my stat plot off. Okay. So now go back to y equals, and now we're going to type in that equation. Negative 16x squared. I know it's t squared on the paper, but I don't have a t. I'm going to use an x for my calculator. Plus 60x. Okay. Now I got to set a window. All right. So to set a window, I could let x max or t max be 0, but I maybe want to see what happens right at the very, very beginning. So maybe I'm going to let that be a negative 2. Okay. Oops. Very good. Clear that and make that negative 2. There we go. Okay. And then x max, well, that's the amount of time it's going to be, you know, the golf ball in the air. And it's really not going to be in the air for very long. Maybe I'll let that be 7 seconds, and I can always change that. Alright, so let's go down to y min. And I don't have to worry about y min being less than 0 because I'm not going to be hitting from some height less than 0. But I might want to let that be negative 2 again, you know, just so I maybe see the bottom axis. Alright, and then x max, I don't really know how high it's going to get, so let's just pick, I don't know, let's pick 75, and then we can adjust it from there. This graph, and let's see how we did. Oh, actually, we did pretty good. That looks pretty good, doesn't it? Okay. So there is my golf ball. And now let's go ahead and answer question A with the calculator. So we want to know at time equals 0, which is the same thing as x equals 0. So here's one way to do it. Second window. And that's where I want my table to start. I'm going to type in 0, which means that's where x is going to start. X equals 0. Second graph takes me to my table, and there it is. When time is 0, height is 0, because height is the y. So the answer to part A is when t equals 0, then f of t also equals 0. So we can write that as, let me erase this piece in here. We could write that as f of 0 equals 0. Good. How high is the ball after 1.5 seconds? Let's use the calculator. And Now we can go to second window. So I want to type in 1.5. Okay. We'll look at our table, and it looks like 54. Okay. So after a second and a half, it's at 54. So F at 1.5 equals 54. That's the function notation. You could just also write 54 feet. Okay, find the maximum height. Let's go back to our calculator. All right, so here, well, let's look at the graph a minute. So the maximum height is where the vertex is. Let's use our maximum feature. Second, trace, and let's arrow down to max. And it prompts you with left bound. So you're going to move your cursor to the left of the vertex, press enter. You're going to move your cursor to the right of the vertex, press enter one more time. So the result is right here. This says at 1.875 seconds, the ball is 56.25 feet high. Maximum height of the ball, 56.25 feet. And again, that was the vertex right up there. When does the ball hit the ground? Well, it hits the ground right over here. Let's do the calculator, figure that out. Alright, so when it hits the ground, going back to the graphing mode, that would be when it crosses the x-axis. So that's when y is 0, and that's also known as an x-intercept. So here's how we find that. A second, trace, go down to 0, press enter, and now it's going to prompt you. And you know what? Let me stop this right now because I want to show you something. I'm going to change my window and show you something. Okay. So you don't have to do this necessarily, just watch mine. So I'm going to let my y min be negative 20 because I really want you to see the x-axis. Okay, there we go. Now you can see the x-axis for demonstration purposes. Okay, so second, trace, go down to 0, press enter. Okay, this is a lot better. See, I want to find that point right there. So it's asking me left bound. So just bring your cursor closer, closer. Okay, good enough. You see it's on the left side of the 0? I'm going to do a blow up for you here. Here's the x-axis. Here's your quadratic. At this point right here, that's when the ball hits the ground. Okay. So when your cursor is up here, do you see how it's to the left side of that? Right. So when it's on top, it's really truly to the left side. Okay. Once we get the cursor down here, that's going to be to the right side. Let's go back and finish that up. Alright, so the cursor's on the left, press enter. Now it's asking me to put it on the right side. So keep arrowing down. Okay. Now here's another way you know you're on the right side. Do you see your y value? See how it's negative? That means it's below the x-axis. So it must be on the right side. Let's go back and look at this a minute. Sure enough, if the cursor is way down here at the bottom, oops, there we go, way down here at the bottom, that means this has got to be a negative y. So then I know I'm to the right side. Press enter. Press enter one more time, and it says 3.75. So that means in 3.75 seconds, the ball will be hit, it peaks, and it comes back and hits the ground. So that was 3.75 seconds. And that's how to use the calculator to do this modeling problem.